Okay, so we are not live from downtown Mill Bay. Hopefully this works. And are we streaming? Looks like we got a connection. We are starting a new section on how to name binary molecules. Molecules because they are covalent compounds. And so the first thing with our previous naming is to tell the difference between ionic or covalent. So, pause the video, take a minute, and determine whether the following 6 compounds are ionic, and we would name them using the naming system we have, or they are covalent. Okay, some rules. NaCl is ionic because it has a metal and a non-metal. And that rule will do you in pretty good stead for most of them. CO2, or carbon dioxide, which gives you a clue, it's named differently from anything we've done before. We have a non-metal and another non-metal. So if we have a non-metal, starts with a non-metal, it's probably covalent. We're going to name using the new system. If it starts with a metal, we probably have something that's ionic. Also, if we see a polyatomic ion, that's a fairly strong clue that we're probably dealing with an ionic compound, because it's not just a metal, although magnesium is a metal, but a cation and an anion. That is what truly makes something ionic. So magnesium sulfate, ionic. N2O4, non-metal, and a non-metal. So covalent. NH4Cl, this is a polyatomic cation. So this is positive, that is negative, so that makes this ionic. One of those few cases in which it looks like it is a non-metal, but it's actually a polyatomic. It has a positive charge, so that makes it an ionic compound. We call it ammonium chloride. H2O, we have a non-metal. We have a non-metal, and so this is covalent. And if we wanted to get really technical, we would call it dihydrogen monoxide, although that is not its actual name. So an ionic is a cation and an anion, or metal and non-metal. And we often, or metal and polyatomic. And the polyatomic could go in either slot. A covalent is just 2 non-metals. There's no metals, or indeed there's no ions. In fact, that's probably a better word here. No ions at all. So in this section, learning to distinguish metals and non-metals and when they're combined, so we can distinguish ionic and covalent. Ionic is how we've been naming things up until now. Covalent, which is all non-metals, particularly a particular type of non-metals, is what we're going to use to do our naming with binary molecules. You actually already know this system. For example, pause if you can, but you should be able to name this. What is CO2? What's the common name? It's carbon dioxide. So pause for a minute. What is CO3? If you had to name that using the pattern carbon dioxide, what would we call CO3? Carbon trioxide. CO4, carbon tetroxide. It's a rule of English. They don't like A's and O's together. So it would be tetra, say nitride if it was a different compound, but we drop the A when it's with O. So carbon tetroxide, CO5, carbon pentoxide. CO, a deadly gas. Carbon monoxide. Not monooxide. When there's two O's in a row, we drop that as well. So we drop one of the O's. So nobody, for example, would write carbon monoxide. Whenever we have a pairing like that, we just drop the other O to make it just sound better. C2O, dicarbon monoxide. C2S2. So we're going to change our second element. Dicarbon disulfide. So we can already distinguish a couple of rules from this. Probably you're able to guess most of these. The number at the end becomes the prefix for that element. So we name it normally. We have the first element, carbon. We name the second element, oxide. We do the same "ide" ending we've been doing all along. And then that too becomes the prefix. So carbon, we name that, and then trioxide. So that 3 goes there. Carbon tetraoxide. So there are 4 oxygens. There are 5 oxygens here, so it's carbon pentoxide. Now, there's only 1 oxygen there, so it's carbon monoxide. Only 1 oxygen. Notice we don't say monocarbon monoxide. We drop the mono on the first element. It's just the rule of what we do. Monocarbon monoxide just was designated as too much of a mouthful to say. But for every other one we do, so if we have a 2 there, that goes to the carbon. So it would be dicarbon monoxide, because that's a 1. And the 1 would go to the monoxide because it applies to the oxygen. C2S2, so we have our carbon, and there's 2 carbons, so it's dicarbon. And it's 2 sulfides, so it's disulfide. With those rules in mind, try naming the following: C3O4, ClF6, SF4, P2O7, N2O4, and H2O. Okay. Tricarbon. 4 is tetroxide. ClF6 would be chlorine, hexa, fluoride, SF4, sulfur, tetra, fluoride, P2O7, diphosphorus, heptoxide, N2O4, dinitrogen tetroxide. And then H2O, dihydrogen monoxide, or its technical name, we've actually changed it. Whenever you see H2O, you can make it. The technical name is actually water. Okay. In order to name them, you do need to know all the prefixes. The prefixes are given in your data booklet, but it is handy to be able to remember them. So write down the number to each one of these words as I go through, and then afterwards I'll do that and check it. Mono, meaning one. Next one is di, meaning two, because everybody rides their dicycle with two wheels. Three, tri, meaning three, because everybody rides their tricycle with the three wheels. Tetra, meaning four. Tetris comes from the same root, the video game based around the different arrangements of four blocks. Five is penta. Six is hexa. Seven is hepta. Very close to the French with sept. They both come from the same root. 8, like the octopus. Octa. 9 is nona. And 10, like 10 years, is deca. These are on your data booklet if you need to look them up, but it is so much easier if you have them memorized. So, formula to name the first element with the appropriate prefix, omitting mono in the first one. 2, name the second one, end it in "ide" like we have been. Also, it is monoxide, not monooxide. It is non-oxide, not nona-oxide. English just has rules about what vowels you can put together. And if you have trioxide, we never drop the I. So trioxide is fine. We wouldn't drop that I. That sounds good. So try these four going backwards. Given the name, work out what the formula is. Tetraphosphorus, so phosphorus is P, tetra is 4, oxide is O, oxygen, deca is 10, so it'll be P4O10, carbon tetrachloride, so chloride and carbon, so carbon is C, there's nothing in front of it, which means it must be mono, so it's by itself, chloride, Cl, and tetra, meaning 4. Dioxygen, so oxygen, O. Di, meaning 2. Fluoride, F. Di also meaning 2 here, O2F2. And then carbon disulfide. Carbon, whoa. Carbon by itself. No mono, but no other prefix, so it must be 1. Sulfide, meaning S, and di, 2. When you're looking at the name, if there's no mono on the first element, so if it's just carbon, then it must mean monocarbon. There's no double O's as a reminder. Never reduce these. We would never take O2F2 and make it smaller because it is a molecule, and it is that particular, it's not a repeating pattern we reduce, it is O2F2. OF would be an entirely different compound. Last, this is as far as we're going to do today, there are 3 that you have to have memorized that have special names. One is that dihydrogen monoxide is actually just called water, and you may find it as dihydrogen monoxide, but its technical name is water. And so H2O has a special name. One I hope you're familiar with. Nitrogen trihydride is actually called ammonia, the same stuff that's in many cleaning compounds you probably have in your house. So NH3 is ammonia. You'll notice on your table of polyatomic ions, there is NH4 plus 1, and that's ammonium. These are different. I remember the difference because ammonium is a longer word, so it has more hydrogens. Longer, more H's. I don't know if that'll help you, but it helped me. Ammonia, smaller word, less H's. And the last one is methane, like methane gas. Methane gas is CH4 and not carbon tetrahydride. Methane is CH4. It is commonly referred to as methane gas. There's a whole other naming system, methane, ethane, propane, butane, all the different gases or compounds you may have heard of, but the only one you need to know for this year is methane. We will stop here. Practice doing some of the covalent naming in the worksheet provided. There should be some posted online as well, and we will pick up from here next day. Oh, I should mention one more thing though. I'm going to skip way ahead. This is like page 9 or something. So skipping way ahead, the elemental gases. There are, on your periodic table, elements that exist as gases that you can react. We're going to ignore the noble gases because they don't react with anything. But we have hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So it makes the picture of a 7. And there are 1, 2, 3, 4, 5, 6. And 7 with hydrogen. So there's 7 of them. There are those ones, and that is on planet Earth. When we say nitrogen, we mean N2 gas because that is its natural form. In the same way that when we say copper, the metal, we mean copper solid, like you find in the ground in its pure elemental form. So the pure elemental form of all of those gases, if we say hydrogen, that is H2. If we say fluorine, that is F2, chlorine, Cl2, bromine, Br2, iodine, I2. So if any of the naming it refers to chlorine, bromine, nitrogen, oxygen, sorry, missing one there. Oxygen is O2 gas. So they always dance in pairs. There are 7 of them, 1, 2, 3, 4, 5, 6, 7. So I did get them all on here. So that would be the 7. Oh, should have included nitrogen in that one. And those ones are the ones, when you refer to them, we always refer to them as their diatomic form. They always have 2 molecules. So if I say bromine, I don't just mean Br, I mean Br2. If you're reading a compound, you have to name something. If it's just in its elemental form, it's in its most common Earth-like elemental form, which for chlorine is Cl2. So we are actually going to stop there. You can have some worksheets to work on and practice, as next day we are going to start on some probably chemical reactions.